Hello, everyone. Some of you may have seen the movie Monsters, Inc., which is a great movie, but you also might have seen the making of Monsters, Inc. And so I'm going to do a couple of videos here as I'm just playing and processing institutional um, change here. I'm going to do a couple of videos showing you the whole process, but really mostly showing you one of the insights that I've found, little tiny holes in some of the instruction with some of the basics. And this is all, of course, around, and I'm going to show you here now. I'm going to go to the green. I'm in that level. I'm over there. I'm going to pick the green, and I cannot do that. Let me see if I can do this. Go on there. I'm going to pick a color. Green. Greenish. Greener. Green. Close. Does it let me do it? Now I'm writing like Sal does. Okay. So what I'm doing right now is I'm going to go File and add a new layer here. And that new layer is going to be what I draft on. You're going to see why, because later on I'm going to get rid of the transparency. And what happens, however, when I do that, that green also disappears, which is not necessarily good. But now this green, because I'm drafting on the new layer, does not. So we're going to use that. I'm going to see if I can do a little bit of an erase. We're going to use that to just take this really basic concept and right away take it into some fun work with transparency and Sketchup for no other reason that I just figured out how it works. So how's that? So I'm going to erase all that, which I necessarily can do. Now, because I'm not on this layer, go back to that layer and I can erase that. So this Smoothdraw, you see a lot of people asking what Sal Khan uses. This is what he uses for his writing, and so I'm going to go ahead and just kind of go now to the point of the content part of this. And this has been my insight, looking at a lot of great stuff, and I'm going to be looking at how to learn the least amount on the unit circle that gets you the most value. So the first thing you have to learn, eventually you'll see about, look within Sal, that there's that all general bit of which trigonometric functions, and the trigonometric functions being sine, cosine, tangent, and then a lot of more, cosecant, secant, and cotangent. But this I tend all soil teachers confuse. All students take calculus, not all state technical college. And so that is something that eventually you run to, but you have to give some names to things here, and that can be maybe not oft-putting, I think, for parents more than for kids. The kids like sines and cosines. They got no problem with verbiage. They know what. But so they've got their own vocabulary, and it's not bad to teach them that stuff. So they do think they're going college math, but you might want to back them into it. So this is what you can do: is you just look at the circle and talk about the firsts and the seconds. So now I'm going to kind of draw this. Again, I'm getting rid of, and this is the part now that we'll take to the next level and make it a little bit bigger, more than I would. Draft a circle here. It's green. Best circle I've ever made. And that circle, if you think about it, I'll bring the dot down here, is centered in my head at least at 0, 0. And right here and here, you're at 1 and 1. So I'm going to go ahead and try like Sal does and put a different color here and bring the brush down. I'm not going to do the text, but I'm going to point that point right there is at a point of 1 and 0. All right. And that point right there is at a point 0 and 1. What I'm now going to do is I'm going to go ahead and this is where you don't necessarily show people, you see people showing you the geometry at the same time as the numbers. I'm going to split that line in two. I'm going to split that line in two. And that's going to give me 1 point here, 1 point there. And then if I take a line through here, a third point there. So I'm going to now change the color on that. I'll draw what eventually becomes a 30-degree angle, a 45, and a 60. Now, later on, you're going to see what we're all going to go back to is this lowest angle that we draw, and then everything is going to be a multiplication of that. So this is the classic way to teach the unit circle, and it's a great way, nothing wrong with it. So what you now do is you open the parentheses for that point, and you open the parentheses for that point, and this is where I always run out of room. I'm going to continue to run out of room here. I'm going to open parentheses, 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 and you just now do number pattern. And how I teach it in class, which I don't have anymore, is comma, 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 chameleon. But I'm going to say over 2 here, over 2, over 2, over 2, over 2, over 2. So that's easily a repetitive pattern for students. And then 1, 2, 3, 1, 2, 3. The square root of 1, you can actually put it there if you want for students, and then square root of 2, the square root of 3, square root of 1, square root of 2, square root of 3. And there they have essentially what is mostly, I would call, best practice. But if you notice in that, I'm going to go down to another color, the yellow, again, seeing how this will transfer. You're missing in that depiction, you're missing the 75 and you're missing the 15. And in that is the conundrum, because in all reality, that angle there, 15 degrees, is the same as 1 hour of spin, which is the same as 1/24 of 2 pi, which is pi over 12. And so the number pattern that emerges for this, I'm going to put out here. It's a little larger. And this is what I've never seen, though I've seen it in Wikipedia. The number pattern for the values there is this. It's a number pattern that lays exactly within. It is 2, 4, 6, with that being the square root of 6 plus the square root of 2 all over 4, and again 2, 4, 6, with a minus in between. Now, where this comes from, eventually you can see it comes from the half-angle theorem, or it just comes from reality. And of course, then that up on top here, if you want to fill in the chart this way, then becomes open parentheses 2, 4, 6 with a minus there, and then 2, 4, 6 with a plus. In other words, you've got, in effect, you have got a symmetrical line here that runs along, a line of symmetry that runs that way for this circle, and we'll look at that in a little bit. So what I'm going to do here, just so we can see the process, I'm going to show here now, that's the basics of learning the first quadrant in the unit circle, but in all reality, you really want to teach students to learn just the first half of the first quadrant. And in this now, I'm going to show you this, do this segue out to how to actually start using some fun stuff going from program to program. You've learned a huge concept here. Now learn to drape it and play it in a number of ways. Now this is, again, not so good because it's my writing, but I'm going to go now to background here, and I am going to export layer image and stick it out in a PNG format. I think you can still see that. It's going to go out because PNG retains the transparency. I'm going to go maybe AA, bad use of it, AA. I'm going to turn my keyboard on, unfortunately. So instead, I'll just put it back on top of junk 3. So I'm putting that hopefully where I know it, junk 3. I'm going to save that, and there it is. So I've pushed this out. Now let me go to finish this out, how, in effect, it should end up looking. And I'm now go to that file, new. I will say no. And so what you end up teaching students to then winnow to is a circle here. Boy, my circles are getting better when I concentrate. And with, of course, 1 and 0 here, and 0 and 1 there, and then that, and that, with basically them knowing that this angle here is pi over 12. And you'll see later on that becomes a little bit easier to manage. So this is pi over 6, and then this is pi over 4, because that's pi over 2. And in those values now, I would tend to have students then not only do the cosine and the sine, but also the tangent, based on the fact that the tangent of this one is 1, the tangent of this one is 1 over the square root of 3, and this one here is going to be a little bit weirder, so I will say on this one it's approximately pi over 12, which it's not, but it gets them to know something called a small angle approximation. And now you're back to the what? Square root of 2 over 2, the square root of 2 over 2, and they might want to know this is 1 over the square root of 2, and then the square root of 3 over 2, and 1/2. It's farther in the x than the y, and then over here, I'm still not going to fit it in, but that 2, 4, 6 pattern with a plus, comma, that 2, 4, 6 pattern with a minus, and this one outside here is not so bad. So that's where it goes into the 15 degree. And so this, of course, is pi over 4, this is pi over 6, and this is pi over 12. Now, what they can then start to play with, and it's important to realize that there's a lot more of really understanding that all angles should then be measured from the standard position angle, either positive or negative, etc., etc. But they can eventually get the value of any angle by comparing it to some angle within here. If you're within this area, you're just going to take the values as given, and if you're within these other areas, you're going to flip the areas. You're going to flip the values, so you know that actually up here at that, it's not the plus first, but it's the minus. So I'll rework this many times, many ways, but that's not bad stuff. It eventually gets students to deal with all these manipulations for matrix transformations or gaming without ever mentioning the words of sine and cosine and tangent, which I have, but you don't have to, which sometimes, if the concept of lattice method is any indication, parents freak out at, right? So I'm not going to talk now about the movie Freaky Friday, but the day that your kids bring home the lattice method is a Freaky Friday for all of us. All right, so I've done this. If you notice here on the background layer, I don't know that I can do this, but now I'm going to export. I'm not going to import. I'm going to close that up. I should have put that on a different layer, but I'm going to export the layer image, export it to there, save it out, yes. And now I'm going to keep going on this real quick just to show you why one does that. Close out the Smoothdraw here, no, bring up Sketchup 8 or any Sketchup program and show you effect what's kind of neat. Again, open source tools, start using SketchUp. The kind of neat stuff that you can immediately do in a classroom, or just heck in the corner bar if you got your laptop, to very quickly take something that was scribbled and make it maybe a little bit more funner. So I'm going to now, in this point, go File. I'm going to import, and I'm going to import these things as an image. So I'm bringing that image in, open. When it comes in, you'll notice it's probably a little bit, that's probably good. I'm going to zoom. There it is. That image has transparency to it, if you notice there. So now, just for grins, I'm going to try and put a ball here. That's a transparent image. I'm going to make a ball that's about that big, and I'm going to zoom out a little bit here. And I'm going to now, if you don't know how to run SketchUp, just give it to a kid and come back about an hour later. They will have figured it out. Now I'm going to zoom in here, and I'm a big proponent of sketchy physics. But you notice there's some transparency to that, and I'm going to now cast that upon the ball. What I have to do first, I'm going to right-click, and I'm going to explode the image, and then I'm going to go now to the paintbrush and suck it up. It's a little bit different on a Mac. I've now sucked up that image, and now I'm going to double-click inside here, and I'm going to drape that image, and it'll drape down to the top and the bottom, but you get the picture. So now here, if you notice, close the group, take that and erase it, and now I've got this kind of double image here, right? Not so good, not so good, but I've got something that's basically pretty wild, especially if finally I'll explode the program here when I do this, but pretty wild stuff, because that, if I go ahead now and do view and turn off the edge styles so it doesn't see profiles, I've got this kind of concept of these equations floating in space, which you can start rotating, etc. So I'm going to go ahead and leave it there without having cleaned this up, but you can get the picture of how quickly you can pretty make some wild stuff. I'll take the risk here. I won't take the risk, but using sketchy physics will make that ball roll, and really fun stuff. So immediately I can see some of the uses of this kind of circle math is all I'm going to call it. Coming up for a better word, you want to avoid the word trigonometry in the short term. Personal belief, it isn't about triangles as much as it's about triangles inside of circles. Thanks for listening. I hope that's informative. And the last thing I'm putting into the circle, which keeps getting filled over and over again, is the tangent of 12 degrees. But remember, the tangent of pi over 12, it's pretty much very much close to the angle if the angle is in radians. So along with doing this, it's this importance of introducing the concept very early, 4th grade, of the radian being the most logical definition for an angle. And I don't see that so much coming everywhere else, but it is a personal belief from mine now after having processed this for a number of years. Thanks for listening.